What if you could take an idea in your mind and materialize it into the real world one tiny step at a time? This is the power of 3D printing, a process that builds objects from the ground up, transforming digital blueprints into physical form with stunning detail. Get ready to explore the world where imagination takes shape layer by layer. Imagine building something not by carving it away, but by adding incredibly thin layers. This is the essence of 3D printing, a revolutionary technology that transforms digital design into tangible objects, bringing ideas to life with remarkable precision. From intricate prototypes to personalized creations, the possibilities are virtually limitless. I always wanted a 3D printer for my DIY projects, so got one. This is the Anycubic Kobra 2 Neo. Have to say, very clean packaging from the Anycubic team, and I have my Android tablet which will help me assemble it. Here we go. Alright, so you snagged yourself an Anycubic Kobra 2 Neo. Nice one. This little beast packs a decent punch of entry-level machine. Let's break down some of its key specs in the way it's easy to digest. First off, its headline feature is its speed. It can hit a maximum print speed of 250 mm per second, which is noticeably faster than your average 3D printer. Though the recommended speed for a good balance of quality and speed is around 150 mm per second, this means you'll be spending much less time twiddling your thumbs and waiting for the print to finish. Now you might be thinking, okay, cool, layers. But how does this magical box of feeling and beeping actually work? Well, picture this. You have a fancy hot glue gun on steroids. But instead of the sticky white goo, it spits out molten plastic. Sometimes even fancy stuff like wood-infused filament, which is just showing off now, frankly. This super precise nozzle dances around like a caffeinated robot, doing some very intricate jig, carefully laying down these super thin lines. Think of it like the world's most patient, slightly obsessive pastry chef, meticulously piping frosting. But instead of cake, well, a plastic cube, a tiny Oda, or whatever your heart desires. Each layer is squished down onto the one before it, kind of like a gentle, plasticky pancake stack. And trust me, you don't want to mess up the order of these pancakes. You just have to be patient. Go grab a coffee, maybe binge watch a season of your favorite show while your plastic pal is hard at work. It has got a pretty decent volume size of 250 by 220 by 220 mm, giving a good amount of space to bring your big ideas to life. The LevelQ 2.0 automatic leveling system is a real lifesaver, especially for beginners. It's a 25-point system that intelligently compensates for any slight unevenness in the build plate. It also has a smart Z offset adjustment so that you don't have to mess around too much to get that first layer right. The Kobra 2 Neo has an integrated direct extruder, which is a motor pushing filament right next to its hot end. This gives you better control over the filament flow, which is particularly helpful when you're printing flexible materials like TPU. Speaking of hot end, it has a 60 watt unit which can quickly heat up, paired with the 700 RPM cooling fan, which makes the freshly extruded plastic which comes down cool fast for a better detail. For the build platform, it's got a spring steel magnetic plate. These are fantastic because when the print is done, you can just flex the plate slightly and your print pops right off without struggle. It supports common filaments like PLA, ABS, PETG, TPU, giving a good variety of material to experiment with. You will also feed your design via a microSD card or Type-C. The whole machine is relatively compact, weighing around 7.3 kgs. It's also built with a modular design, making the assembly pretty quick and easy. You will be up and printing in no time. Overall, the Anycubic Kobra 2 Neo seems a solid choice for getting into 3D printing world without breaking the bank. layering. Who knew building things could be, well, nerdy and awesome at the same time? And that, my friends, is how you go from a digital dream to a physical reality. One perfectly, or sometimes wonky, layer at a time. You have got your digital 3D design, usually chilling as an STL or standard triangle language file. Think of it like a basic shape description using tons of tiny triangles. It knows what it is, but doesn't know how to become real. Alright, so you have already seen the whole 3D printing shebang. Might seem like pure magic at first glance. A digital file proofing into a real world object. But when you peek under the hood, you realize there's a whole symphony of incredibly precise movement, carefully controlled processing happening. Think about it. Your printer is precisely heating plastic just at the right temperature, pushing it through a tiny nozzle with micromillimeter level accuracy, and then moving that nozzle in 3 dimensions at just the right speed, all while coordinating fans to cool everything perfectly down. It's a tiny specialized robot performing an intricate design thousands of times to build your creation layer by layer painstakingly. And then you have got the software side of things. The digital design, the slicing algorithm, figures out the optimal paths for printing. The G-code telling your printer its every move. It's fascinating blend of engineering, software and material science, all baked working together in harmony. So while the idea of pushing a button and getting the physical object is super cool and becoming more accessible every single day, we should not forget the incredible complexity humming away inside this box. Now your 3D printer is a bit of a control freak. It needs super specific instructions. That's where G-code stuck in. It's a language you use to boss your 3D printer around, telling it where exactly it has to move the nozzle, how hot it has to get, or when to squeeze out that plastic. How do we go from this triangle party in an STL file to this bossy G-code commands? Enter Slicer software. This is your printer's personal translator and operations manager. You feed in the STL file, tell it how thick you want the layers, how the inner support or infill you need, and if you need a little helpers or support for those tricky overhangs. Thank you for watching the video. I can safely say there are many more 3D printing videos in line. Also, if you have any questions about the Anycubic Kobra 2 Neo, you can put them in the comment section down below. I'll try to answer them with all my knowledge.